At Solar Farm 2.0, we have panels that tilt in one axis. So they start off in the morning facing east. By the end of the day, they're facing west. So as they turn, that changes the light environment. We weren't really sure how big an impact these would have. Ideally, if we can get close to the yield we would get in full sun under shade, and then we get the energy out, it's a win-win. We use a term called the land equivalent ratio. What is the value of combining? And so I think of it as you have an acre of solar and an acre of crops. If you can get the same production from those alone on less than 2 acres, that really says this is a viable idea. If it's not, then it doesn't make any sense to combine them. I think there are some crops we can find that will actually yield equal, if not slightly better, because there are some plants that are shade adapted and like having some shade. Anytime you do research, there's a ton of variables that you've got to look at. And this year we planted 3 crops. We planted sorghum, soybeans, and clover. We tried to pick short stature crops. Wheat would be another. We didn't look at wheat, but the sorghum is certainly kind of the corn alternative that doesn't get nearly as high. So we're looking at photosynthetic efficiency. How is that affected by the amount of shade? So we're taking measurements every week. How much chlorophyll is being produced, color and so on. Things like soil temperature, air temperature. The other issue which we're still working on doing is panel performance. How the plants grow can affect the panel's performance. If they get too hot, they start to lose efficiency. So if you get cooling from the plants growing there, as opposed to having bare ground, for instance, you're going to see a more efficient use, more production of electricity. What we're trying to do is really characterize the growing environment under the panels for plants. For the way we do, our small plot research is typically we're going to plant a large area, but we're going to sample a relatively small area to get an idea of the yield of those plants. When we're growing something like sorghum or soybeans, it works out pretty nicely because you have these rows with spacing in between where there's no plants. Our clover is continuous, and so what we're seeing is that as you move across there, the light environment changes. So the outside rows are going to see the biggest impact. We're seeing those responses this year. We're measuring the responses. We're really getting that light environment characterized within those panels. That's really the goal of this year's research and next year as well, to see how well that replicates. Really what matters is the dry weight of the grain, but also the plant itself. When you have those different light environments, the moisture contents are different. So, the fresh weight really doesn't tell you much. You've got to look at what the dry weight is. What's the total dry matter produced? So we collect the heads of the plants, the seed, and then we collect all the biomass as well. And so we separately characterize those. We're going to do that by randomly sampling a relatively small area, maybe 6 or 7 plants that we'll use as representative of the entire environment there. The exciting part after all this is to see the yields we're getting and to allow us to then start planning for what we want to do next year. When you get those numbers and you get to run statistics and see exactly what happened out there. And I was really encouraged by those results because the overall yield loss, statistically, it was not different. That's really exciting because that means that combination is really going to be efficient. We can design systems to work with farm equipment, to be able to have panels that you can upright, run something right down the middle of it, then let them collect energy all summer long and then put them back up, harvest, and you're out of there. And I think whether it be corn or soybeans or whether it be wheat or pasture crops, I think this is really going to have an impact down the road. I don't know how long it's going to take, but certainly this is the start.